Happy Monday! Yeah, so that was a drugstore that exploded in Marietta, Georgia on Halloween 1963. It was kind of it was a tragic event. Some people found it on Facebook and posted in the comments, and I posted it on YouTube. Anyways, so that was from a batch of films that I got from a guy who had a box of 16 millimeter newsreel outtakes. Basically, he got them from the cameraman who shot them. And so there's parades in there, there's assorted Atlanta stuff, but that's in there as well. Kind of fascinating. Tragic, of course, but, interesting history nonetheless. So it's the beginning of March. It's our 301st streaming show. So thank you so much for everybody for joining in on Friday. We are working on sending out prizes to people. And thank you so much, everybody, for the coffee that you donated. You donated more than you normally do, and I appreciate that. That was a really kind gesture. But also, the fact that you guys tuned in also made it really a lot of fun. And Katrina and I were talking about how we enjoyed the whole thing. So thank you so much. We have so many more films to watch. And then, I keep acquiring new films, so I'm actually talking to somebody who has a list of films that they want to send me. So that might be a month from now. But we're just still chugging along here. We're still going. So on a tangential note, let's learn about the pipes in your house. Oops, that's not right. That's wrong. Let's learn about riding on your school bus.
The rest of you listen to what we're going to talk about, too, because the class may be taking bus trips together this year. So this will be important for all of us. Now, who can remember what we talked about yesterday? Kurt?
Obey the driver and don't cross the road until the signal starts to.
Well, those are two good points that we'll talk more about in a little while. But what should you remember even before you get to the bus stop? James?
Leave on so you won't miss the bus.
Yes, leave your house early so that you arrive at the bus stop a few minutes before the bus. What is something else we talked about that you should remember on the way to the bus stop?
Don't play around on the way.
Yes, go straight from home to the bus stop. We also discussed a very important thing about where...
Walk facing the...
Yes, if there are no sidewalks, walk on the side of the road facing traffic. That way, you can see cars coming and stay out of their way. After you stay back away from the road, and be careful someone doesn't accidentally get pushed into the street. Don't pile books which is in the road. And don't drop trash around the bus stop. When the bus arrives, stay back from the road until the bus comes to a full stop and the door is opened. If you must cross the road, wait until the driver signals. Even if there is a patrol, wait for the driver to signal before you cross. Now, when getting on the bus, what should you remember?
Not to crowd.
That's right. Don't crowd. And use the handrail beside the steps. After you are on the bus, take a seat and stay seated until it is time to get off. Don't put books and lunches in the aisle for someone to trip over. What are some of the other things you should not take on the bus? Allison?
Cans,
James?
snakes,
Kurt?
bottles, dogs,
Well, you're all correct. Soda bottles or cans should not be taken on the bus. And if you have your lunch or any other food, you should not eat on the bus. And, Eckley, you're right. Live animals should not be taken on the bus, even if they're pets. Now, what should you do if you want to get off at a different stop? Allison?
get a note
Get a note from whom?
from my parents,
Yes, that is right. Get a note from your parents ahead of time and make sure they say when and where you are supposed to get off. Then take it to the principal and have it signed. Your driver can't let you off at any stop except your own without a note. So, unless you have permission, always ride the same bus and get off at your regular stop. Never put anything out the window. This includes arms, hands, clothing, and anything else. Who can think of a reason not to put things out the window? Kurt?
well, that's because the bus comes close to trees and things.
Well, that's one reason. Often the bus comes close to tree branches, road signs, or cars and trucks. You never know when something is going to come by, and if you had your hand or arm out the window, you could lose it before you knew what happened. Don't throw anything out of the bus. It could hit someone or hit a car and cause an accident. It also makes a mess.
We shouldn't throw trash in the bus either.
Right. The driver has to clean up the bus every night, and you can help by remembering to pick up all trash you drop. Don't mark on the inside of the bus. Buses are expensive to operate. Repairs are often paid for by those that caused the damage. Don't yell or shout while on the bus. Just talk loud enough for the person sitting next to you to hear. And never throw anything in the bus. If the driver is distracted from the road, even for a moment, that may be long enough to cause an accident. Remember, bad behavior could result in your losing the privilege of riding the bus. Now, who remembers what we said about the emergency door? Kay?
You said never to play with the door.
Yes, never open the emergency door unless told to do so.
I found out that there are really two doors that can be used in an emergency.
You all remember what she's talking about. Yesterday, when we had our drill, remember how half of you went out the front door and the rest went out the rear? Who can tell me how you knew which door to use?
The door that is closest or easiest to get to.
Wait your turn and get out as fast as you can. If a patrol or older person is at the door, let them help. After you are outside, get into a group away from the bus and traffic. Stay together so the driver can see if anyone is missing. Have any of you been on a bus when a student was driving?
My brother drives the bus.
Remember, if a student is driving the bus, you must obey him, even if it is your brother. Don't joke or play tricks on them while you're on the bus, even though you might be very good friends. When you arrive at your stop, stay seated until the bus stops. Then don't push or crowd. Wait your turn. Use the handrail when getting off. When you have several books, carry them so you can see the steps in front of you. If you must cross the road, wait until the driver gives you the signal. Cross far enough in front of the bus so you can see the driver and he can see you. If you must walk back beside the bus, stay away from the side. Now, who remembers what we said about taking rides from the bus stop? Tina?
Don't ride with anybody you don't know.
Yes, even if it's cold or raining, walk on home if your parents aren't at the bus stop to meet you. If you miss the bus in the morning, go back home and let your parents bring you to school. Now, that was a good review. Don't forget what we've talked about. It might save your life or the life of a friend.
So I rode a school bus almost my entire elementary and high school career. You know, the time that I basically rode. Well, I think my senior year, actually, I didn't ride a. I did, well, okay. No, I did ride a school bus. So I didn't have a car. My friends had cars, but because of divorce, I ended up in a rural part of North Carolina, and my bus didn't pick me up there. So I'd get dropped off at high school my senior year, and then I would take a bus home and be with my mom, and my dad would pick me up. Anyways, more information that you need to know. But anyways, I spent a lot of time on a school bus, and what it turned into was eventually that's when I would do my homework in the morning, or I would sleep, or whatever, because I would have a very long, like more than an hour long bus ride, because rural North Carolina. Anyways, I was talking about pipes in the house. Here they are, pipes in the house.
Have you ever been lucky enough to go out camping in the woods by a mountain stream? It's really fun. Well, most of the time it's fun, except that water always seems to get heavier the farther you have to haul it. You know, 100 years ago, children had to do this every day. Not many children lived where water was brought right into the house in pipes. If you lived 100 years ago, you just couldn't do this. Or this. Or this. But today in your home, all you have to do is turn a handle to get a tub of water. Simple as that. Wait a minute now. Is it so simple? Have you ever stopped to think of all that has to be done before you can get this water to scrub your legs? At least we hope you scrub. Of course, you know that the water comes in pipes. In new houses, you've seen the pipes sticking up through the floor. This is going to be the kitchen, and the plumber is putting in the pipes to the kitchen sink. The pipes run down under the house. If you follow one of them, you'll find where it comes from a larger pipe outdoors. And this pipe will lead you to a big water pipe in the street. Do you know where this water comes from? For many people, the water comes from a reservoir, a lake where water is stored high in the hills, sometimes many miles away. And to get from the reservoir to the house where you live, it flows down through a pipe. Do you suppose that everybody has to run a pipe 10 miles or so from the reservoir to get his water? Wouldn't that be foolish? No, the people join together to bring the water in one big pipe. Then whoever needs water can run a pipe from the large one. Perhaps you have a reservoir like this near where you live. There goes the water starting on its trip to your house. It goes over hills and across valleys. But before it reaches you, it must be made pure. Would you guess that tumbling water like this will kill germs? It does. Sunlight and air kill some germs here, and other germs are killed with chemicals. When the water reaches the city, it flows through pipes called water mains. These men are just putting in a new water main. From the water main, pipes go to your house, so you can water the lawn or squirt your brother. Pipes bring water to every bathtub, to every mother's washing machine, to every thirsty boy and girl. Yes, it's a lot easier to get a drink of water this way than this way. When our friends are out camping, it may be hard work getting the water, but it's certainly no trouble getting rid of it. Just imagine, though, what it would be like if everybody in a city did this. Wouldn't that be a mess? But at home, down the drain it goes. Simple as that. Of course, it's really not that simple. Let's explore the new house again. The large pipe that the plumber is working on is called the waste pipe. That pipe will take the water from the kitchen sink down under the house. Here it comes. And here comes the waste pipe from the bathroom to join it. Then, in most houses, the waste flows out to join a sewer pipe under the street that carries the waste away. There they go again. First water, now wood for the fire. It really is fun to help with the chores when you're camping. But just imagine having to bring firewood in every day so you can cook. If you lived 100 years ago, that's what you'd have to do. But now, you just turn on the gas. Easy. Easy, that is, after the gas gets to your house. A gas pipe looks just like a water pipe, and it comes up from under the house like the other pipes. Do you know where the gas comes from that finally gets to your house in this pipe? In some places, gas comes out of the ground, often where oil wells have been drilled. Large pipes bring the gas many miles to the places where it will be used. But not all gas comes from far-off oil fields. Much of it is made from coal. Here is an experiment that shows how gas is made from coal. First, we'll break up some of the coal and put it in a coffee can. Now we'll heat it on a burner. After 3 or 4 minutes, gas and smoke will begin to come out of the hole in the lid. If you get your father to help with this experiment, wait until your mother goes away on a long vacation, because it will make the house smell terrible. Whether the gas comes from a gas plant near your home or from far away, it is usually stored in a huge gas tank. From the tank, it comes through pipes under the street to you. Gas comes to heat the water so you can wash your ears, or heat the frying pan so you can have a hamburger. Isn't that a fine thing to have coming right into the house in a pipe? Here's another job that the campers don't have to do when they're home: cleaning the lamp and filling it with kerosene. This is a chore that every boy and girl did before we learned to use electricity. But at home, you'd think it was strange if you couldn't go into your room and do this. Do you know how the electricity gets to your room? Let's watch an electrician at work in the new house. Here is the place where a light switch will go in the wall. The electricity will flow to the switch through these wires that are protected in a kind of pipe. If you follow the wires, you'll find they lead to a pole outside the house. If you keep on following the wires, you might find that they lead many, many miles out into the country, over hills and valleys. They might lead you to a power plant near a reservoir. Water drops down from the reservoir through great pipes to the power plant. The power of the falling water turns machines. When these machines are turned, they make electricity. Perhaps you can understand better how we get electricity if we do an experiment. Here is a small machine like the very large machines that are turned by falling water. To make electricity, we'll really turn our little machine by hand, but we'll make believe that it's being turned by falling water. Here are the wires leading out over the country, over hills and valleys. Here is the light that you turn on every night. And now you are in your room at home. Let's suppose that the water in the dam begins to turn our machine. Watch. In this same way, electricity comes to light your real home at night. It runs the vacuum cleaner, and makes the fan go, and turns the electric mixer. Electricity helps to make your home a good place to live. It's fun to go camping, but it's fun to get home. It's good to turn a handle to get water when you're thirsty, or when you want to scrub your legs. It's good to have gas to heat your bath. Good to have electricity to light the bathroom. Water, gas, and electricity. They all make your home a better place to live.
That was great. Wait till your mom goes on a vacation for a long time because it's going to stink up the house. So good. Hey, thank you, Matthew, for the coffee. You can buy us coffee by clicking on the link that I'm pointing to, buymeacoffee.com/avgeeks. I needed coffee this morning. It was gray, and that caffeine boost was what I needed to kind of get the day rolling. So thank you so much for that. All right, I got a film threaded up here on the Telecine. This is the film transfer machine that I use when I'm doing the show. And I used to use it a lot when transferring stuff, but there's so many folks wanting things at HD or 2K or 4K that I basically have to do things on a film scanner. And so I have other machines that I use. But this is still pretty handy. I bought it new from Germany, and it's about $60,000, which took me a while to pay off. But it's a great thing, and it was just sitting there at the archive, and I was just like, well, let's bring it into the basement. All right, so anyways, a lot of talk. Here is Safety 3.
It's beautiful when you know what you're doing and you do it right. Driving is beautiful too, when you know how to do it and you know that doing it right is the only way to go. You get more out of almost everything you do when you have the skill and self-confidence of an expert. A really good driver is a special kind of person. Everything he does shows that he is in full command of his car and himself. Not everyone has what it takes to be an expert. Many people lack some important quality, whether it's knowledge, training, physical coordination, or the right mental attitude. They just can't get it all together. Being an expert driver calls for some special skills. Yet many of us spend so much time in our automobiles that we sometimes forget how much ability it really takes. For example, in an average mile, a driver may make as many as 20 decisions that affect his safety and the safety of others. Decisions to speed up, to slow down, to steer, or to stop. Often these decisions must be acted upon in split seconds and with very little room to spare. Sometimes on a narrow road, vehicles traveling at high speed may be separated by only a few feet. Less elbow room than people like to have when they're dancing. Not all of us are athletic or even sports-minded, but some of the skills and attitudes of star athletes may help anyone do a better and safer job of driving. Like a first-string football player, an expert driver has to make quick, accurate decisions. He needs to be constantly on guard against anything the other fellow might do. For example, when the driver of a car ahead makes a sudden left turn from the right-hand lane. A varsity quarterback needs judgment, coordination, and the ability to think one play ahead. So does a driver need to think one play ahead, especially where parked cars might conceal possible interference. Football calls for accurate judgment of time, speed, and distance. So does merging smoothly into the flow of freeway traffic. Both driving across the goal line and driving in traffic call for fast thinking, fast reactions, and keeping your mind on the game. An athlete knows instinctively what his muscles can do for him. Every driver needs the same knowledge of his car and what it can do. For example, at 30 miles per hour, how quickly can his car stop? Under average conditions, the car will travel about 25 yards before it comes to a standstill. If the road is slippery, the tires or brakes are worn, or the driver's reactions are slow, the distance needed may be more than double. At 45 miles per hour, even under the best of conditions, an emergency stop will use up nearly half the length of a football field. At highway speeds, the distance between goalposts may not always be enough. That is why the driver who knows the stopping ability of his car never tailgates. He always keeps a safe distance behind other traffic. An expert driver carries a mental picture of how speed affects all of his driving decisions. For instance, at 30 miles per hour, he needs more than the length of a football field to overtake and pass another car. It takes about another half of a football field to get back into line, but that isn't all. To allow for traffic approaching from the opposite direction at about the same speed, the distance must be doubled. So for safe passing at about 30 miles per hour, we need a clear space ahead of 3 to 4 football fields. When traffic is moving at highway speeds, a much larger safety margin is needed. The average passing maneuver will use up 5 to 6 football fields. So we need a clear distance ahead of about 12 football fields, nearly 3/4 of a mile to allow for oncoming traffic traveling at high speed. In almost everything we do, knowing how to do it right makes the difference between ordinary performance and outstanding performance. When an unskilled driver loses traction on a slippery road, he's likely to go into an uncontrolled skid. It takes skill and quick thinking to get everything under control. Some of the world's most experienced professional test drivers have developed advanced driving techniques and driver training methods for better and safer handling of emergency situations. According to these research drivers, the right action, taken quickly enough, will keep a little skid from becoming a dangerous skid. To correct a skid, the car is steered in the same direction that the rear end is sliding. It takes sensitivity and quick, firm action on the steering wheel. The instant the car begins to respond to the correction, the steering wheel is turned back to its original position. Do not use the brakes or the accelerator. Because many drivers are unsure of how they would handle a sudden tire failure, driver education research has developed a training system. A special device, controlled by the instructor riding in the front passenger seat, can instantly deflate any of the tires while the car is moving. The tires can also be quickly reinflated. Here's what the research drivers say. Do everything possible to keep the car traveling in a straight line. When you have control, use the brakes very gently. If the car starts to swerve, steer to correct it. With today's tires, you're not likely to have a blowout, but as an expert, you won't be caught off guard. You'll have both hands on the steering wheel, ready to take quick action. Even an expert may find himself off the road and driving on the shoulder. For the inexperienced driver, getting back on again safely may be a problem. There are 3 steps in doing it right. First, steer away from the road edge a foot or so to give the off-road tire room to maneuver. Then steer firmly so that the off-road tire will aim for the road edge at an angle. As the off-road tire strikes the edge of the road, immediately steer back to get the car moving in its proper lane. The key steps are allowing the tire room to turn, steering at an angle that will let the tire climb the road edge, making the final correction the moment you sense the tire striking the edge. The best drivers know that a car can't be steered when the brakes are full on and the tires are sliding. The secret of control is to let the tires roll just enough to regain their grip on the road. If the car starts to swerve, ease up momentarily on the brake pedal and steer until you get control again. Making a quick stop straight ahead is one of the most important driver skills. But sometimes putting on the brakes isn't the best thing to do. This could be one of those times, but actually, it's a stage training demonstration for advanced drivers. This demonstration shows that at high speeds, or when there isn't time or room to stop, it may be possible to steer around an obstacle. It also shows the extreme stability of the modern automobile. On hard, level pavement, even with the most violent steering, the car keeps its balance and can be kept under control with all 4 wheels on the ground. If you have your mind made up to be an expert, you can safely practice some of these emergency skills whenever you are behind the steering wheel. What would you do if that truck just ahead should spill part of its load directly in your path? All it takes is imagination. Would you know instantly how to keep control if water or oil on the road ahead should cause a loss of traction and a skid? If you should have a blowout or accidentally drift onto the shoulder, would you remember what to do, and would you do it right? The automobile has come a long way in being easier and safer to drive. It's engineered to help the driver avoid accidents with better brakes and better traction so he can stop more quickly when he needs to. With better steering and stability so he can steer to avoid an accident. With better suspension and better balance to help him keep control on the roughest roads. With more responsive power, the driver can use quick pickup to get out of a dangerous situation. Wider glass areas give an unobstructed view all around so the driver can spot hazards before they become dangers. A constant goal of automotive safety engineers is improved protection of driver and passengers. Here in slow motion is one of many thousands of tests to prove the ability of the modern automobile to protect its occupants. When driver and passengers wear properly adjusted lap and shoulder belts, the finest cars give them the maximum protection available today. At these proving and testing facilities, the engineers have designed and operated the world's safest road system, with an accident-free safety record many times better than the national average. Millions of miles of safer driving. The concrete wall in this bridge is an example of the way safety can be built into a highway. An automobile striking it is eased back safely into its own lane with little or no damage. Highway authorities all over the country are now using these engineering principles in planning and building new roads. New concrete highway dividers reduce the possibility of head-on collisions. Roadsides and obstructions are guarded by steel rails engineered to reduce damage to cars and danger to the driver and passengers. Embankments are shallow so that vehicles may drive over them with little damage. Light poles like these are designed to break away when struck. Small roadside signs are built high enough to pass harmlessly overhead if hit by a passenger car. Safer cars on safer highways help to reduce accidents and cut down on the damage they can cause. But it still takes a driver who understands and accepts the responsibilities of being the man in charge behind the wheel. Some drivers seem to have a king-of-the-road complex. Even kings make mistakes. Driving is a full-time job. Goofing off, thinking about something else while you're driving, can be embarrassing and sometimes costly. It doesn't pay to take your worries or frustrations with you when you sit behind the steering wheel. A driver who is angry, seeing red, may be blind to approaching danger. No first-rate driver stays behind the wheel when he is sleepy. Danger has a habit of suddenly popping out of nowhere. Driving under the influence of alcohol causes more than half the traffic fatalities in the United States. You can see why no good driver wants to try it. Alcohol is a drug. Any kind of drug can slow down your reactions, confuse your mind and your senses, and make you look really stupid. No one can be expert in anything when he's stoned. When a real expert is doing them, things look easy. Smooth coordination of mind and muscles are what makes it so great. The same kind of coordination makes a good driver smooth and relaxed. And wherever he drives, he does it with easy precision and self-confidence. Having confidence in yourself makes it easy to be courteous to other drivers, to give the other fellow a break instead of insisting on being first all the time. Giving the other drivers a break also means giving them plenty of warning when planning to change direction or to slow down. A good driver is thoughtful of pedestrians. After all, he's a part-time pedestrian himself. The driver who wants to do it right all the time, all the way, is especially careful where children might be playing. Being able to do things just a little bit better and more smoothly makes everything we do more fun and life more worthwhile. We do a lot of living in our automobiles, and much of our joy in living comes from being able to go wherever we want to go, free from worry and safe from harm. Going safely depends on three things: a car, designed, engineered, and built for safety; a road, built to eliminate hazards; and a driver who knows what he is doing and does it right. Safety times 3 depends on you.
Sorry about that. I know that some people wanted to see what year it was. And it was another film from 1972. Hooray! 1972. That was pretty great, although it was very male-centric. So, yeah, there you go. Thank you, William, for the coffee. Much appreciated. This next film I wanted to show you, I need to fix this real quick. It's about shoes. Shoe manufacturing. Love it. If the shoe fits.
One thing we 130 million Americans have in common with the rest of the world, we all walk. And one of the things in which we excel most people is that we walk in better looking, better fitting shoes than any other people in the world. You know, you can read character in people's own story every time. Science tells us that as civilizationist, man acquired certain foot differences depending upon his mode of living. And usually these physical differences became hereditary. However, no scientific study had ever been made of these many foot variations until the manufacturers of Thom McAn shoes created the foot device. With this ingenious device, men set forth to hundreds of Thom McAn stores to undertake the task of accurately measuring thousands of customers' feet. Measurements were made of the length of the foot, the thickness or height of the foot at the ball joint, the elevation of the arch, the width of the foot at the ball joint, the diameter or thickness of the heel, measured from side to side at the point of maximum thickness, the curve of the back of the heel. These and many other measurements were recorded together with accurate tracings of thousands of foot outlines. From the scientific data thus compiled for the first time in the shoe industry, expert last makers were able to design a variety of almost every normal foot. Each of these lasts was then made in 40 to 60 different sizes and widths, a selection large enough to fit most normal feet. And the story of building shoes on these wooden foundations of fit is an interesting document all by itself. To learn this story firsthand, I visited one of Thom McAn's New Hampshire factories, and here I saw the selection and inspection of the highest part of the hide. It's been specially tanned for toughness and long wear. Then I saw these tough bends being cut into outer soles and rigidly inspected for imperfections, brand marks, or anything in the hide that may have spoiled the appearance or wearing quality of the sturdy leather. Next, I saw inner soles being rounded to conform to the bottom of the last, so that each shoe will be the correct size and ensure proper fit. In the operation known as channeling, 2 parallel cuts are made around the inner soles near the edge. Then the leather between these diagonal cuts is turned up to form a lip. This is important, as you will see, for later the welt and upper are stitched to this turned up lip. To reinforce the inner sole and add strength to the turned up lip, a tough canvas is cemented to the inner sole. The operator called this gemming. The canvas is then trimmed exactly to the edge of the lip. Sorting leather for the upper part of the shoe is a very important job. Here I learned that the best upper leather for shoes comes from calfskin because of its fine glove-like texture. So skilled are these inspectors, they can tell at a touch or a glance the quality of each piece of leather. Cutting the parts of the upper is one of the most skilled operations in the manufacture of shoes. This part, known as the vamp, must be cut so that the stretch of leather will be from heel to toe to help retain its shape throughout the life of the shoe. Each style, size, and width of last must have its own set of cutting dies. The tip is perforated to add style. More than 150 styles are created each year by the designers in this factory. A reinforcing flannel called the doubler is cemented to the upper to give it further body and strength. This helps the shoe to keep its shape. And then the upper begins to take form as the tip is stitched to the vamp. Each part is matched and correctly joined. This is an operation requiring the ultimate in skill and precision. The perforated quarters are stitched to match the tip and vamp to which they'll be joined. The quarters are the two parts that form the back of the shoe. Joining the quarters is called back seaming. In top stitching, the completed lining is stitched to the joined quarters. I was amazed to find that even with the most modern machines, the operation of them calls for a high order of skilled craftsmanship. Eyeletting, another operation that calls for precision. The line of eyelets must be in just the right place. The upper must be temporarily laced in order that it may be properly lasted. The final operation on the upper part of the shoe is known as vamping. The vamp, with the tip attached, is stitched to the joined and lined quarters. A small piece of leather reinforcement is added at the point of greatest strain, where the center of the vamp is attached to the upper. Now, with the upper completed and the inner sole ready, the assembly of the finished shoe begins. The inner sole is tacked to the wooden last, the foundation upon which the shoe is to be built. Next, the counter is inserted. This gives support to the heel and shape to the back of the shoe. The completed upper is then tacked to the last from which the shoe takes its shape. Next, I was surprised to see a truly amazing machine of more than 5,000 moving parts, whose ingenious steel fingers in one single operation pull the upper over the last and tack it tightly, building comfort and fit right into the shoe. Then came the side lasting operation, pulling the upper snugly over the wooden last and stapling it at the side for temporary security, another important step in building fitting qualities into the shoe. Upon these operations depend to a great extent the ease and comfort of the shoes you wear. With heel lasting, the joined quarters are formed and fastened at the heel. Then I watched the bed lasting machine wipe in the upper and fasten it at the toe. This operation gives the toe of the shoe its final shape. By this time, the many intricate manufacturing steps I saw in the making of just one shoe began to give me a keener appreciation of the footwear so many of us take for granted. Then I saw the famous Goodyear welting machine, invented more than 70 years ago by Charles Goodyear. Today, Goodyear's perfected method, used in manufacturing all Tom McCann men's and boys' shoes, is considered the nearest to perfect construction ever developed by the finest master craftsmen. Tough, specially treated leather goes into the welt, which is sewed through the upper to the lip of the inner sole. This is the connecting link between the upper part of the shoe and the outer sole. A shank is inserted to support the arch of the foot. And then ground cork filler goes between the inner and outer soles to act as insulator and cushion for the foot. Under heavy pressure, the outer sole is attached, preparatory to the rounding and Goodyear stitching operations. Rough rounding trims off all excess leather and shapes the sole to the lines of the last. And then I saw the Goodyear stitcher securely fastening the outer sole to the welt. Just visualize what's happening. The needles carry two threads which come in from top and bottom, crossing and forming a loop in the middle, thus securely fastening the outer sole to the shoe. Now a heavy roller called a leveler molds the sole to the bottom of the last, particularly under the arch. This adds to the comfort of the shoe. The heel base and leather top lift are nailed on from below. Edge trimming with sharp revolving knives requires a steady hand and an artist's eye. This operation gives the shoe its final character. Hot vibrating irons pound the edge of the sole, giving it a firm and highly polished surface. Wax and polish are applied for further protection of the sole. The welt and upper are cleaned and beautified. Now that the lasts have served their purpose in building a shoe to fit, they're removed and the shoes are ready for the final dressing. Liquid wax is applied with a spray gun to add luster. I was amazed to learn that there are 208 major operations in the manufacture of Tom McCann shoes for men. The finished product is a tribute to the skill of the New England craftsmen I met. Skill inherited from their forefathers, whose tradition of making fine footwear they so proudly carry on. The same high standards that guide the craftsmen in selecting the raw materials and in building the shoes are also to be found in the retail stores, where 143 million pairs of these shoes have been sold since 1922. Here, highly trained shoe salesmen see to it that every customer gets the proper fit. They know that from the scientific findings of the Pathofoot device, from the handiwork of expert last makers, and from the precision manufacturing methods of the factory, have come a line of fine footwear in a multitude of sizes, widths, and styles, from which nearly every normal foot can be perfectly fitted. And these salesmen realize, too, the great responsibility which they share with the manufacturer, the responsibility of giving every customer the comfort, wearability, and dependability to which he is entitled. I got some good advice from these shoe folks, advice that I'd like to pass along to you. It's found in the old saying, if the shoe fits, wear it.
Oh, wow, that film was great. Lots of wonderful manufacturing. Let's see. I was looking to see if I could find something that talks about when the film was made, and I'm not finding it. I missed the title to see if there was a year, and a place that I often look for information about films. WorldCat doesn't have this particular film listed, so there you go. You know, let you guys do some research, see if you can figure it out. if it didn't say it in the title. You can oftentimes look it up via. There's this Media Lantern, which is a website that is a university site that has a bunch of stuff that they scanned from different trade magazines and periodicals that came out about film. And so this would be something I would look up in Business Screen, which is a trade periodical specifically for companies that make sponsored films. And so this film would be shown at Tom McCann's, but it would also be rented out for free to civic organizations, because it's the interest of like, well, how do they make shoes? And this shows the process. Of course, it's all talking about Tom McCann's manufacturing process, but it could be applied to general things as well. Really fascinating. That was from the Oregon Film Archive, where we scanned a bunch of films for them, and that one's obviously a little splicey, but beautiful, beautiful footage. Thanks everybody for tuning in today. We'll be back tomorrow, Tuesday, and we'll watch some more films, because that's what we do here. Thanks again, everybody, for the coffee. William, did I say thank you to you? But yeah, coffee is great. We love it. And we'll start sending out prizes to people this week. So you will see your prizes, those who participated in last Friday's show. So everybody have a good day. As always, please rewind and love each other. And we will see you again soon. Take care.